To my channel that's write some more cheat code. Today's video is about solving this question, maximum frequency stack. So when I let's read out the description first. So we're designing a stack like data structure, right? And we have two operations. First is to push, the other is to pop. This is just like a normal stack push operations. But the only difference is the pop operation. So we always remove and returns the most frequent elements in the stack, right? Not the most recent added elements, but instead we have to remove and returns the most frequent elements in the stack. Now there is actually another requirement where when we have a tie for the most frequent elements, then we need to remove and return the last added elements. Basically, we still need to preserve the last in, first out feature of the stack when there is a tie. So when I first look into this problem, right, since we want to remove the most frequent elements in the stack, we need to keep track of the frequency in the map, right, in the stack, basically. So that said, we implemented this with like we can have like a map, right? We can have a map data structure where we have these to be frequency, and then we map that to the elements at this frequency. So take this as an example. When we push phi, first we have the frequency 1 map to like the elements which has frequency 1. So when we push phi, it's actually in here. And then the next we push the 7 in here, right? It looks fine. And then when we push phi again, do we store it in here? No, because now we have phi to be at frequency 2. So we need to create like a map from 2 to phi. Now we keep track of that, right? So far it is correct. But then now here is the key points, right? Because when I first look into this problem, I was thinking that since phi has a frequency 2 now, do we need to remove this one, the phi here, and then move it to 2? Well, sure, we can do that. But then what happens when you pop the phi, right? Now say phi is at the max frequency, so when you pop, you actually pop phi, and then when you pop phi again, you need to kind of we need to push it back to the frequency 1. But then if you push it back, it's actually, say it's in here, right? And then it kind of just screw up the order where phi needs to be in front of 7, right? So, well, you might argue that, okay, we can just push back the phi into the front instead of here. But what if you have, let's say, what if you have a 2 in here? Now if you insert it into the front, it also screws up the order where you have 2 and then 5 and then 7, right? So to preserve the order, we cannot simply just move it back. Then what we are going to do, it turns out that we don't need to remove the phi over here at frequency 1, because when we remove this phi over here, right, we can just simply go back to the frequency 1 and look into the phi here. So when we once pop the 7 again, and then we can go back and pop the phi here. So and also what I observed is that we always pop this phi first before we pop this phi. So we don't really need to clean it out here, right? And we shouldn't, because we need to preserve the order when phi is at frequency 1. So I guess that's the trick for this problem. And then just let's continue to work on the problem where we push another 7, and we have, say, 4 in here, and we have phi to be at frequency 3, and then now we are popping the max frequency and the most recent one, out of the stack. But then how are we going to know if this 3 is the max frequency? So one thing we can do is to say we put this right into the map. If it's a sorted map, we can retrieve the max elements in log of n time. But do we really need to do this? Do we really need to put this into a sorted map? No, we don't, because we can actually just do a hash map here where we don't need to sort the keys. If we have another say variable called max frequency, right? And we can just keep track of that. When we add the phi here, we can just remove, and then we keep track of the max frequency to be 2 and to be 3. When we pop the phi, we can also remove this max frequency and we can switch it back to 2. We can keep track of the max frequency in here, and then we can have a time complexity of 1. So I guess that's the question. That's the solution for that, and the time complexity for both operation is in O of 1, whereas the space complexity would be O of n, right, in linear time, in linear space. Yeah, so that's the explanation for the question. Let's move into the coding part. So let's start the coding part. So I have this data structure to draw out for a better explanation. So here is our frequency map from the frequency to the elements pushed into the stack. And we also need to keep track of the frequency of each element. Otherwise, every time we push an element into the stack, we need to go through the frequency here and say, okay, let's push a 2, right? We need to first look at it. We have that in frequency 1, and then 2, and then 3, and then so on. But if we have a frequency map, we can fetch the frequency of that single element at the constant time. So first we have an order map that keeps track of the frequency of the elements, and then we need actually another hash map to map from the frequency to the elements at that frequency, and we code a frequency to values. And then when we push a value into the stack, we simply need to keep track of the frequency at this element. So what we can do is to fetch the elements, and then we increase its frequency, and then we also need to push that into the map over here. So then we can have frequency to value of this frequency, and then push the value in here, right? And whenever we push the elements, remember the max frequency that we need to keep track of. We say that if the current frequency of this element is bigger than the max frequency, then we need to update the max frequency equals to this, right? So, and for the pop, right? For pop, we simply need to pop. For this case, we pop phi. We need to remove the max frequency elements. So we can go to the max frequency and then do a pop, and we check if the frequency to value, right? Basically, if we check the frequency of this frequency of the elements. So because we need to return that value after popping it, we also need to save the value before we pop max frequency top, and then if the value, if we don't have any elements in here, say we remove the phi, right? We decrease its frequency to 2. If we don't have that frequency anymore, we need to decrease the max frequency, right? And that's basically it. Oh, and we also need to return the value here. That will be the solution, so that's run it. Yeah, it's pretty efficient. And that will be today's video. Thanks for watching. Please like and subscribe. We will see you next time. Bye bye.